Hello. Many of you guys asked this question from the class. We have a trapezoid, and given that we have one line segment that is parallel to two bases connecting the other two legs. So let us try to look into this question together. Let us say this is A, B, C, D, and E, F, given in this way. Now, intentionally, what I'm going to do is EF is not the median, not necessarily the median of this trapezoid. In fact, I'll say the ratio of AE to, let us say, ED, let's call that as maybe it looks like about 1 to 5. Now, where AB is equal to, let us say, 12, and DC is equal to 18. And we want to figure out, find EF. So how do you do this one? Once again, given that all three line segments are parallel to each other. One of the first things which we can do is this. You can draw any diagonal, whether it be AC or BD. Oh, let me just call AC right over here. Now I'm just going to change the color just so that we can see better. This green line segment is the diagonal that I have drawn. Then in this case, one thing that which we get to realize is this. You see, the one that I'm highlighting right now with yellow, that becomes one triangle, where this portion, we see one small triangle and one big triangle must be similar to each other. And let's call that point as maybe a point M. Then in this case, we get to realize that triangle AEM is similar to ADC. Then what will be the ratio between those two triangles? Since AE is equal to 1 to 5 ratio, I don't know the exact length, but the ratio between small to big triangle will be 1 to 6. Combining the big thing, entire line segment, 1 to 6. That will be the ratio. Then, since we know that DC is equal to 18, and let me call this portion as maybe X. Then we get to write up a proportion in a way that 1 to 6, which is small to big triangle, that ratio must be X to 18. Then what do we end up getting? That's right, by cross multiplying, we get 6x must be equal to 18, where x equals 3. So we get to realize that this length will be equal to 3. All right, then let's go for the other line segment. So I'm going to use the green. And if I have, as you can see, this green, we have two similar triangles once again, but it will be upside down triangles. Since this side is equal to 12, and let's look at it. So since the bottom portion is 5, while the upper portion is 1, the ratio CF to FB would be still 5 here, and 1 here, which means entire thing will be equal to 6. So in fact, between small triangle to the big triangle on the right side, the ratio becomes 5 to 6. Now, in the same manner, we're going to call this side as maybe Y. Then what will be the proportion which we can set up? It will be 5 to 6 will be equal to Y to 12. Then we get to realize that 6Y will be equal to 60, where Y becomes 10. Then this becomes 10. So therefore, what is the entire line segment? EF, it will be simply addition of 3 and 10 together. So therefore, it becomes 13. All right. So in fact, this was great. And another thing which we could have done was this. We can go backwards. Let us say I have another parallelogram. Now, Let me see. I call this one as A, B, C, C, D, E, F. Of course, all three line segments are parallel. And I'll say this time AB is equal to, let's call it, let me just tell you the ratio first. Let's just do it, AB is equal to 10. And then EF. In fact, EF, let's call that as maybe 12. And we want to find out DC if AE to ED is equal to 3 to 2. So now, that means when we draw a diagonal, right here, we end up getting two sets of similar triangles once again. Since the upper portion is 3, while the lower portion is 2, as an example, and so is the other side, 3 and 2, where this side is equal to 10, and EF, if I were to call this one as M, EF is equal to 12. Well, let us try to find out what this one is. So let me call this one as maybe A. Then we get to set up the relationship where 2 over entire thing, which is 5, has to be equal to A over 10. Then by cross multiplication, we get 5A will be equal to 20, where A will be equal to 4. So we realize that this line segment is equal to 4. Now, if you know that this is 4, while entire thing is equal to 12, what is EM? That's right, EM must be equal to 12. Out of 12, subtracting 4, which we end up getting 8. Now, then, by moving on to the left side pair of triangles here, pair of similar triangles, we get to realize 3 to 5. You see, 3 was the upper portion, which is part of the triangle, and then 5 is the entire triangle. That has to be equal to 8, which is part of the same small triangle, over DC. Then what do we realize? Yes, 3DC must be equal to 40. And what is DC? DC will be equal to 40 over 3. All right. So these are the two sets of questions which we can work with in a trapezoid with another parallel line segments to their bases. Thank you and have a nice day. Bye.